Of course, most of you joined the newsletter, so you will be the first to receive the news and updates. So you will always know what is happening with the project. But we also have a Twitter page, which is the main place where we share what we do, the events that we attend, the changes in the library, and so on. Before we start with the actual presentation, I want to thank those who are actively supporting the openhdemg project, that are the University of Brescia, the university where I work, with Professor Francesco Negro, that is providing a lot of support to me to carry on the project. He is not able to join today, but will likely join in the next classes to say hi, to make a bit of an introduction of him also. And then the University of Basel, that is instead supporting Paul, which is the main developer of the graphical interface of the openhdemg project. Okay, so today we are doing the first coding class. The first class will be very basic, obviously, and we will look at how to install the openhdemg library and how to load files and understand their content, so their structure. This is loading a file is the first step we do when we want to start doing some analysis. But it's also going to be very useful to explain you the basic concepts in coding. So we will look at what are strings, what are arrays, and many other things that are the main building block, let's say, of your coding knowledge, your coding skills. Okay, before we go to the actual presentation, I want to tell you that on the GitHub repository of the openhdemg project, you can see here the link, but also the QR code if you want to scan it. We created in the discussion forum of the repository, we created the coding class event. Inside this event, you can find all the important information about this and the next classes. Here we will upload all the code that we use today. So you will have all the finished and polished code for yourself to practice a bit. But in this same place, you can also ask your questions, you can tell your doubts, and you can ask for our help, okay? So if you encounter any challenge in understanding the code or making it work, just go inside the coding classes and write your question, and we will try to answer as soon as possible. So the one thing that you can easily do to support these classes and the openhdemg project overall is to go on the GitHub repository and leave a star to the project. A star is the same as a like on Facebook, Twitter, or wherever you want. So it's just a form of appreciation of the project that we are carrying on. It seems a stupid thing, but it's not, because it's what determines, with other factors, of course, but it's what determines the credibility of a project. So when somebody approaches a new project on Python, usually has a look at the number of downloads it has, and the number of stars that it has, and so on, how much it has been developed. So if you can leave a like or a star to us, this is very much appreciated. Okay, so today's agenda is quite long. We will try to condensate it as much as possible, but at the same time, we don't want to rush through the topics because otherwise these classes will not be helpful to you. So we will start today's presentation with a very short presentation of the openhdemg project, because on YouTube you can find a much more extensive presentation of that. And then we start talking at why we are doing the coding classes. We will present the objectives and the future planning of the coding classes, and then we go immediately into the more, let's say, interesting parts. So we'll talk about the fundamentals of Python package distribution. So where is the openhdmg project hosted? And once we understand this, we also understand better why we need to install the openhdmg library in a certain way. And we will also see how to do that. After this preliminary setup of the project, we will start with the proper hands-on section where we start coding ourselves. And don't worry, you don't need to write the code live in real time. You're free to do that if you want, but otherwise just follow the concepts and explanation that I give to you. Then you can go back to the video at any time you want, and you will have all the codes to double check or to verify that your implementation is going to be correct. So we will look at the structure of the openhdmg file, and we will learn all the important data types in our work. And then we look at a couple of basic constructs in the Python language, but more or less in any coding language, that are the for loops and the if-else statements. With these few elements, we will write a very short script that will display you the discharge rate of motor units, okay? Just to give a meaning to all what we are doing, just to show you that we are not learning coding for itself, but we are learning coding to make something useful of our work. And then, as I already said, in the end, we will have a Q&A session and a know each other session. So if you're interested in EMG, in the openhdmg project, feel free to introduce yourself. Or if you have any question related to the class, feel free to ask it. You can also write in the chat if you prefer, and you can also interrupt us during the coding session if you want to have a better, a deeper explanation of what we are doing. So openhdmg is a free and open source framework, which is written in Python 3, which has many functionalities that are specifically designed to simplify the analysis of HD-EMG recordings. So with the current openhdmg, what you can do is to open a file, a decomposed file that is coming from a number of sources. We are trying to allow the users to open more or less any kind of file, so coming from one software, another software, a custom implementation, and so on. All of them with the same structure that we will see later on. And once we load this file, we can process it, so we can prepare it for the following analysis. And then we can do all the major, at this point, analysis of motor units properties, going from the very simple ones, like motor units recruitment and the recruitment threshold, going to the more complex ones, like conduction velocity estimation or tracking of the motor units. But being all this in the Python ecosystem, we can also expand all the already existing functions to do the analysis with the various Python libraries that allow you to do statistics, to do plotting, to do signal processing, and so on. But I think this presentation may have raised a few questions. So, like, for example, what does open source mean? Open source means that every line of code and even the description of the code that we built over time is completely open and available to any of you. So you can go in our GitHub repository, you can look at all the source code, you can verify it, you can criticize it, you are more than welcome to improve it, and you can even modify it to better fit your different necessities. At the same time, so this is what can be defined a library, but openhdmg is a framework. A framework means that it has different components. The first one is obviously the library, but then we also have a website where we put some tutorials, we put all the instructions to use the library, we put the dissemination activity that we are doing. Parallel to this, we also have a discussion forum, as we have seen before, where people can ask for help, can provide suggestions, can share their experience, and this is useful to build a community. And then we have a graphical user interface. A graphical user interface is not software, but is a better and easier way to interact with the library. So the graphical user interface is a collection of, let's say, buttons and figures and text that simplifies the user interaction with the functions that are contained in the library. And we noticed that most of the people using the openhdmg framework are using the library. And this is understandable because this is are using the graphical user interface. This is understandable because it's expected to be the easiest way to perform the analysis. And that's true, it is the easiest way, but it's obviously impossible to implement all the functions and all the possible variations of the functions inside the graphical interface, because you will need to populate it with thousands of buttons, drop-down lists, etc. So it will be a mess. Therefore, if you can perform the analysis that you need with the graphical interface, that's fantastic because you have a very convenient and fast way to do your analysis. But if you want to customize your work, and even more, if you want to automate your work, you will need to interact with the library. The library is a collection of functions. And don't be scared because all these functions have been designed with one main goal, which was to be simple. So we didn't build the library to be the most sophisticated tool in the world, the fastest tool in the world. I mean, it is sophisticated enough, it is fast enough, but mainly it is simple because this is the main goal of the openhdmg framework, okay? So why we are using Python? Well, the main answer is that Python is free, so anybody in the world can use it without the necessity of paying a membership like it happens for MATLAB or many other programming languages that are specialized in data analysis, and also because it is very flexible. You can do many different things in Python, not just data analysis, and also because it has a lot of fantastic libraries that are specialized in signal processing, numerical processing, and so on. So why we are doing the coding classes? This is because the openhdmg project is not the project of a few people, but it's a community project. And there are, of course, the developers that are these people that write the code, develop the functions for you. But then there are the users, and the users are not a passive figure. The users are not just receiving the functionalities and using them, but a lot of what we developed so far came from the user suggestion, from the user's experience. So we build something, the users test it and say, hey, look, this is fantastic. Hey, look, this is terrible. We need to improve it. And we start building new functionalities, improving the existing ones. So this is the idea of a community, but we want to go a step further because we want to create a collaborative community. To create a collaborative community, we need to share the vision, which is, of course, to simplify the analysis of motor units properties for everybody. But we also need the users to really understand how the whole project, and in this case, for what we are doing today, how the library works. Okay, so when we manage to build a strong community, this community will be a place where people can ask for help, can share their experience and learn from others. So we can advance, hopefully, the field of HDMG research in a collaborative rather than in a competitive approach. So this is our main goal, and this is why we like to explain you the basics of Python and then to explain you how to use the openhdmg library. Okay, so I think you already got the main objective of the coding classes, but now we also have some more specific ones. And indeed, we want to teach you the Python fundamentals that are needed to fully exploit the openhdmg library. But these Python fundamentals are the same that you will need to do anything else if you want to process some signals or some numbers, or let's say in Python. At the same time, we also want to make you completely independent in the analysis of motor units properties using the openhdmg framework. And I think this is a very important point. We want to make you also understand how the results that you see by calling a function, using the graphical interface and so on are obtained. Because when you know how things are obtained, how results are obtained, you can be much more aware of the peculiarities of your approach, and you can have a much better and more robust interpretation of your data, okay? And in the end, if you really like coding and high-density electromyography, you are also more than welcome to contribute to improve the openhdmg project, because this is becoming a very big project, so everybody's help is much appreciated. The original idea was to do the coding classes every 2 weeks, till the end of the modules. We have no idea how many modules we are going to do, because this very much depends on how you respond to our classes. So if we are going too fast, if we are going too slow, if you prefer to go deeper into some aspects or to go faster, okay? But an important part is that after each class, I will send to everybody let's say an email where you are asked to express your feedback and to evaluate the classes. And there will be some questions related to organizational purposes. So when you prefer to do the classes and so on, because by the time that more people join, also the preferred time or day and so on will change. And the only thing I ask you is kindly, the classes are open to everybody, but I kindly ask you to express your opinion regarding the organizational things only to those that are also interested in the use of the openhdmg library, okay? Because of course we need to prioritize the openhdmg library users. Okay, so let's start with the technical things. So Python is an enormous ecosystem that collects all the Python packages in an enormous repository. This repository is called PyPI. It contains 500,000 of projects. Last year there have been 284 billion of downloads for the project, so it's something huge. And all the Python packages can be downloaded from this repository. If you go on this repository and search openhdmg, what you will see is the main page of the openhdmg project inside the PyPI website. If you look at this page, you don't see any download button. And this is because openhdmg is not a software, it's a Python library. So you cannot download it, double click on it and install it. And no Python library works this way. But the website is telling you that you can install openhdmg with the command pip install openhdmg. So you all received information on how to set up the working environment. So you already went through all these steps. Today we will go through them again, just very quickly, not to teach you how to do this, because I guess you already learned it, but instead to explain you why you are doing things, okay? So this is the tutorial page that you already saw. This page explains you how to download Python, how to download the Visual Studio Code. Of course, you could download any integrated development environment, but we just thought that Visual Studio Code is the best one to start working, and also the one that will allow you to go much further with your coding, okay? So we set it up once for all. So another thing you did, and that we will do again, was to create the virtual environment. A virtual environment is a very, let's say, ideal concept. It's not simple to understand, and most important, it's not simple to understand why we need it. Very briefly, a virtual environment is a box, is a container, is a compartment of your computer memory. Inside the virtual environment, you will have, after its creation, the Python version that you are using, and you will have a set of libraries that you can install. Obviously, you can install everything, Python libraries and anything in your computer without the necessity of a virtual environment. But when you code with Python, you will easily end up having 20, 30, 40 libraries installed in your computer. So it's very easy to mess up where they are located. And it's also possible, of course, to have different versions of the same library. So we can have version 1 of openhdmg, we can have version 2 of another library, version 3 of another library, but we can also have version 0.1 or version 4 of the openhdmg library. And when we download the different versions of different libraries, there is the possibility that these are conflicting with each other. So in order to avoid this, we want to put all of them in a container. If we want to do another project, we put the other libraries in another container, so they are all confined. And if we want to remove all of them, we simply remove the virtual environment from the computer and everything is gone. Okay, no organizational issues. So to install and update openhdmg properly, we do this from the command prompt. So we will use a few commands that are very simple to understand, that are pip install the name of the package to install the package. Then we have pip install dash dash upgrade the name of the package. Then we have pip list that will show us all the packages that are contained in the virtual environment or in any location where we install them. And then in the end, we have pip uninstall that simply removes the package, okay? All right, so all these things in theory don't make much sense, but we will see them working. So let me open Visual Studio Code. This is probably what you saw when you downloaded it the first time. So it is completely empty. There is nothing to do, apparently. If you follow the tutorial, you went on the Extensions tab and you installed, of course, Python. This is not the Python language. This is the Visual Studio Code extension that allows you to easily interact with the Python code, okay? And then I suggest you, if you want, for your better coding experience, also to install Flake8, which is going to help you a lot in the formatting of the code. So it will help you to write a nice looking code. And I also suggest you to install Pylance, which is helping you a lot in automatically filling the code, giving you suggestions on the code and so on. So it will make it even easier to write Python code. Okay, once we installed everything, and you already did, we need to open a folder. Every folder that we open is a space where we can directly interact, okay? So we do not open a script that is located in a random space in a computer. We can do that, although it's not good practice. Instead, we want to have all the scripts that concern a specific project in one folder. So the first time we see this open folder button, the next time this is not going to be here. So you can simply go to File, Add Folder to Workspace. Okay, I have my folder that is named Test Class, and as you can see, it appeared here. So here we have some buttons to create a new file, to create a new folder, and so on. These are very convenient. Let me zoom in a bit so you see better. But I want to introduce a bit to the concept of a command prompt. So we can go on these buttons here. We have the option Terminal and New Terminal. Okay, if we are not that much zoomed, we go to Terminal and New Terminal directly. Okay. So this is a terminal, a normal terminal, a normal command prompt that you have on Windows, you will have it on Mac, you will have on any operating system.
Giacomo, can
And
I interrupt you real quick?
yeah, of course.
Just asking around, did anybody have an error in VS Code when you opened the terminal in the PowerShell? Okay, apparently not. Because sometimes if you don't have all of the access rights on your computer, you will get an error when you open the terminal using PowerShell and not command prompt. This is something that you can easily solve when just Googling it, but just
Yeah,
seeing that you open it in PowerShell.
I think some users had permission errors, but probably they solved them by looking at the troubleshooting section of the guide we have on the website. So
exactly, just making
yeah.
sure. Yeah.
Actually, I had this problem, but it got solved when I just restarted my computer, so then it suddenly worked.
All right.
Okay, that's perfect. Otherwise, we have a troubleshooting section on the guide, the installation guide that you can follow. And there we explain how to force the execution of the scripts on the computer if you keep having issues of this type. Because every computer is produced with a different level of permissions. So the first time you do this, yes, you can have a lot of problems. We tried to put all of them in the guide on our website. If you keep having issues, don't hesitate to send us an email and we will try to help you. And we will also add this specific problem on the guide for the other users. So we are in a PowerShell, so in a terminal, and we can do whatever we do in any terminal. Now, this is not very important for the scope of the tutorial, but for example, I want to put all what I'm doing, all what I'm coding for this first class in a specific folder. So I want to, if you look here, I am inside the directory user, Giacomo, desktop, test class. Okay, but now I want to put all my code in another folder, which I want to call class 1. So I want to make a new directory, essentially. The command is very simple, md make directory, and I call this class 1, okay? If you see here, I now have a folder that is named class 1. The only important thing you need to know when you are using the PowerShell, the terminal overall, is how to navigate between folders, okay? So I am inside the test class and I want to enter class 1. To do this, I need to change directory, which guess how it is written is cd, which stands for change directory, and I write class 1, okay? So if you see here, now I am inside class 1. If I want to go back, I simply write cd ... space ... okay? And I go back to test class. This is the only thing that you really need to flexibly code, okay? Because all the rest can be easily managed from the buttons that you have in your integrated development environment. So let's go inside the class 1 and let's create...
Sorry, can I ask something?
Yeah, of course.
Just what's the difference between the normal terminal and the PowerShell? Or how to get to the PowerShell?
Okay, so the PowerShell is the default terminal that Visual Studio will open. So when you go to terminal, new terminal, it will open PowerShell. Of course, you have the option to use different terminals, and you will see that once we execute a Python script, we will have a Python terminal. So every terminal serves a different purpose. The only thing we really need to do at the moment with the terminal is to activate the virtual environment and to install the necessary libraries. So for that case, PowerShell is the one you need. Okay, but
But
yeah.
sorry, Jacob, since I know that you're probably on the Mac, Romina,
Yeah.
it's not PowerShell that's on the Mac, so you can also just use the CMD, the command prompt, or the normal terminal on Mac.
Okay. Yeah.
However, the commands for creating the directories are a bit different. So I guess on Mac, which is Linux, it's mkd or something like this. I don't remember by heart.
Yeah, you can use mkdir
Yes.
also on Windows. So
yeah. So
I
it should
think
be similar.
yeah.
But everything else you can follow as well with on the normal Mac terminal.
Yeah. Just because that command didn't work, but yeah,
Okay.
I'll look at that later. Merci. Thank you.
So now, in that case, you can try make directory a bit more extensive, which is mkdir, and you can create class 1, 2. So you see it is working.
Yeah,
And
now it works. Thank you.
yeah, okay. And then you have rmdir to remove it, okay?
Perfect.
But I mean, you can simply go here and click a new folder. It's gonna be the same. I just did so because I wanted to show you the change directory command, which can be very useful, okay?
Perfect. Thank you.
Okay, so let's create the virtual environment. So to create the virtual environment, we need to start calling Python. We can do this by writing PI or better, the entire Python. The short PI doesn't always work. It depends on how you did the Python installation. So just to make it work to everybody, we write Python -m, which stands for module. So in this case, we are calling a Python module, which is called virtual environment. Okay, so the virtual environment, you can consider it like a function, VM, that is creating the virtual environment for you. The only thing we need to add to this command is the name of the virtual environment. So I want to call it class and, okay? I press enter. You can give it any name you want. So I pressed enter. I created the virtual environment. It's not finished, so it is setting it all up. Yeah, fantastic. We created the virtual environment. On the terminal, we are back to our directory, so we can write new stuff. And inside this virtual environment, there are things. What we are interested in is the scripts folder that contains some stuff and which is necessary to activate the virtual environment. To do so, we access the class env, and we want to access the scripts folder, and then we want to run the activate command. If we do so, you see now we have a green name, we have green text with the name of the virtual environment, and that means we are inside the virtual environment. We can deactivate it at any point, and we can reactivate it. If you want to go back to the previous commands you used, just press the up arrow, and as you can see, we can navigate up and down arrow all the commands, so we activate it again. We can clear the terminal. So once we are inside the virtual environment, and be very careful to be inside the virtual environment, we can install openhdemg, okay? So in this case, we write pip or pip, which is the tool that we are using to install any Python module. So pip install openhdemg. With this command, we are connecting to PyPI. We are downloading all the necessary things and we are installing them inside the virtual environment. So as you can see, some stuff is happening. Now, how much it takes very much depends on the speed of your connection for the download and the speed of your computer for the installation. It usually takes a few seconds. And as you can see here, we are installing these packages that include, where it is, openhdmg, that should be somewhere around here, and also other packages that are called dependencies. The dependencies are the other Python libraries that openhdmg needs to run. Every library has a number of dependencies needed, okay? And this is why we use virtual environments, because with one line of code, we installed 25 things. And if you need to remove them one by one, it's a mess. All right, we installed everything. It has been successful. And so we can now work on our first script. So we go inside the class one, we create a new file, which I call class1.py. And this is extremely important because it's telling to Visual Studio Code, hey, look, create a Python file because of the extension. And if you look here on the left, now there is the Python icon. If I remove the .py extension and I put, I don't know, CSV, I get another file type. Okay, so you can create more or less any type of file from here just by typing the file extension. This is very convenient. .py. Okay. Now we are inside the class one. Just let me rename this because I want to show you the final script. So we will give you the final script, so you don't need to write everything down. The script is quite long, there is a lot of text. So you see there is a lot of stuff, we will go through it. Don't worry, you will get it all, so just listen to what I say if you want to practice, but don't worry about writing things down, okay? Now the Zoom stuff, okay.
Giacomo, I don't remember. Did we already send the file to the participants or not?
No, I will put the files in the GitHub discussion section after the call. So everybody can download it from there. And I will also send the link in the email to everybody.
All right, great.
Okay, so before we go coding, and today it will be Python basics, I want to start from some basic concepts. English, first of all, because we are not English, most of us, and because I always mess up with the terms, and because some of them are confusing. So, of course, we have the round brackets, the square brackets, the curly brackets, the well-known point, comma, colon, semicolon. And up to here is okay. Also the underscore, it's okay. But something that I want you to be careful on is the single quotation mark. You should see it well enough. Then we have the double quotation mark that are very much different in Python. Then we have this symbol here, which is a minus if you put it between numbers, but it's also called a hyphen or a dash. And we have two dashes that are called double hyphen, M dash, or double dash. For simplicity, today we call this minus if there are numbers, or we call it dash and double dash in other occasions, okay? And they are also going to solve different functions in Python. Okay, so today we look at the data structure of the openhdmg files and the data types. I now introduce two basic Python concepts. We have the asterisk, which is used to comment one single line. Then we have 3 plus 3 double quotation marks that are used for multi-line comments, like you see here, okay? There are 3 here, 3 here. So here my test is starting, here my comment, better say, is ending, okay? Then we have the text between 2 double quotation marks, that is a string, and we also have the text within 2 single quotation mark, that is still a string, but with a lower hierarchical level compared to the string within double quotation marks.
Giacomo, are you sure that the first one is called an asterisk? Because just to add a bit of confusion here, isn't it a
Right,
hash?
but this is why I put the English at the beginning, not for you, but for me. Yeah, you are right. Thank you, Paul. Thank you.
Yeah. I'll put an
Okay.
asterisk in the chat just to make sure that everybody knows what an asterisk is.
Fantastic. Okay, then we have the equal and the double equal. So equal and equal equal. Contrarily to what you can expect, this one is a comparison symbol. So if I want to say that A is the same as B, I will write A equal B. But the single equal is used for assignment. So if I want to say A becomes the value of B, I say A is equal to B. Okay, we will see this. And then we have the brackets. So we have the round ones that are usually, commonly, not always, but usually used to pass values inside functions. Then we have the square brackets that are usually used for indexing purpose, not always, but most of the times. And then we have the curly brackets that are instead used for particular use cases, okay? So let's start with coding. So the first thing we need to do in any Python script, regardless of what you want to do, is to import the libraries that we want to use. It's not like in MATLAB where everything is already installed, everything can be directly accessed, because I know that about 70% of you use MATLAB, so I guess that these differences are worth being highlighted. So to import the necessary libraries, simply write in plain English, import openhdmg. From openhdmg, we do not want to import the entire framework, but only the library. So we do this. If you see, once you put the dot, you get all the possible options that you have. So we have different sub-modules that are the library, compatibility, GUI, and so on. And for today, we want to access library. Now, every time we want to call a function inside the openhdmg library.
Sorry, can I ask a question?
Yeah, of course.
The color of writing is important.
Yeah, the call of writing is extremely important. This is why I suggested you to install the other two extensions at the beginning of when we open the development environment, because the color is telling you what everything that you write is, okay? We
Yes, I
will
got
see
it.
this because this is very important. And I mean, it's not fundamental. You can work in a completely black script, but that's gonna make your life much, much easier.
Thank you very much.
But
You're welcome.
just maybe to add, which color it is doesn't matter. So, for example, my code looks a bit different than Giacomo's because I chose another like theme. But in principle, yes, it makes the life easier. But whether the import is pink or blue or yellow doesn't matter.
Yeah, it will be always the same within your environment. Okay, if you go to somebody else's computer that likes other colors, it might have different colors. But the one I'm showing you are the default colors. So when you install well, I mean, at least with the black theme that I'm using, these are the default colors. So, okay, I was saying that every time we want to access a function, we need to access it from openhdmg.library. So the code is going to be enormous, and that's why we can import it with a short name. For convention, the short name for the openhdmg library is emg. Okay, that's English. So we import openhdmg.library as emg. So for today's presentation, we need other libraries. Now, don't bother about them. We will look at them in the future. I will just import them because we need them, okay? So I import matplotlib.pyplot as plt. The short names, you can invent them, but it's much better to use the conventional names so that everybody can understand your code. This particular library is used for plotting. And then we import time, which is a library used to manage time variables, okay? The first thing we want to do now is open something, is to open a decomposed file that contains some motor units. We can do this by using the openhdemg library. So we do emg, which we imported here, so it's the same as writing openhdemg.library. That, and as you can see here, we have a lot of functions inside it. There are so many functions that, I mean, we cannot look at all of them this way. If you want to look at the various functions that there are in the library, you go to our website, you read the documentation, and you find them. We will do that together over the next classes. Not today, because otherwise it's going to be too much information that it won't be useful to you, because now we look at the basics. So I tell you that the openhdemg library has a function to load a sample file that you download together with the openhdemg library. And this is called emg from sample file. All right. So until now, we saw things in green. If we hover over the things, we see what they are. So openhdemg is a module, library is another module, which being inside openhdemg can also be called submodule. But now we have something in yellow that is a function, okay? You see it from here. If you put your mouse over here, you also have the documentation of the function. This is very short because the function is very simple. You can see that every function, we can pass values inside the function with the round brackets, as I told you before. But inside these brackets, there is nothing. That means we don't need to pass any information to this function. If we read the documentation, it simply tells us that the function is returning the emg file, which is the dictionary containing the emg file. So we will go in the documentation in the next classes, but it's just to introduce you to the concepts, okay? So even if the function doesn't take any parameter, we need to put the round brackets anyway, otherwise it doesn't work. And this way we are importing a sample file, but this file is nowhere in our memory, okay? It will disappear. So in order to make it usable, we need to assign it to a variable. This variable, by convention, is called emg file, okay? And the assignment is done with equal. So what we did here is saying to the script, hey, my variable emg file contains the sample file that is imported by this function. Fantastic. We did something. Now we go in the stuff we should really learn, okay? So this is a basic Python syntax. So we have functions, we need to put round brackets, and the outcome of a function can be stored in a variable, which might be better called object. But if we call it variable, anybody that knows any other coding language will understand what it means. So the first thing that you usually do when you start coding is to display the famous sentence hello world. So in Python, you can do this by saying print, which once again is yellow. So it's a function, then it has round brackets. And we need to tell to this function what we want to display. So we print hello. And if we execute the code here, there is written run Python file. You see a Python terminal is appearing, and we see hello, okay? So we did the first and most useless code of our life, but this is gonna be how we can look at the things, how we can look at the variables, how we can look at the content of the emg file, okay? So I introduce you to here to a string. So we have two double quotation marks. So whatever is written inside here is a string. And we can write whatever we want. You see the color is this dark orange, at least in my computer. So we can say hello. But if we write something strange like \n, you see that it's now yellow. It's not orange anymore, because there are some terms that cannot be strings, okay? \n, in this case, is an escape code. So it won't be printed. So if we execute the script, we'll not see \n nowhere. It's just hello. But instead we see a blank line. So we will use this a lot today to make things much more readable. So if we only print this one, we have a blank line. Okay, you see, there is nothing printed. And we will use this because otherwise all the text is merged together. It's a disaster to read. Okay, fantastic. Now, EMG file is blue. It is blue because it's a variable. But a variable can contain anything. A variable can be of different types. So the first thing we want to do is to see what type of variable the EMG file is. To do so, we write in plain English type, which is a class. Classes are concepts a bit more complicated than functions. We will look at them in the future, but for now we can treat the classes the same way we treat the functions. So it doesn't matter. We still need round brackets and we still need to pass some values inside the brackets, okay? So now I need to do something that might be a bit too much, but this is necessary to explain you things. So take for granted how we call the functions, how we read the documentation, the differences between classes and the functions. We don't care now, because now we are going through the basics. We look at data types. You will see that in the future we will explain everything and you will understand everything step by step. So if you write type and simply EMG file, it is going to print the type. We put another blank line, because I like blank lines. And as you can see here, this is a class, as I already told you, but we don't care what the class is. But the important thing is that it is a dict, which stands for dictionary. This is a Python dictionary. We can print this a bit more descriptive. So in this case, we use, we create our string, and we use curly brackets. As I told you before, curly brackets have very particular use cases. In this case, it is used to format a string. We can format a string by simply writing F, and as you can see here now, everything inside the string got colors, so we can combine text with variables, okay? So I want to simply write EMG file is of type, and this will display the type, okay? And there we go, EMG file is of type dictionary. So formatted string are very simple. You write F, you write your text, and whatever you want to pass that is not text, you put it inside curly brackets. That's all what it is, and then there is not more to know about that. Okay, so let me take stuff from here, and let's learn what dictionaries are. So dictionaries, you don't need to write it down. You will get all the code and all the description. So dictionaries are versatile data structures that can store key and values pairs of any data type. And interestingly, the values can be complex objects. So my dictionary can contain with the key A, can contain a number, can contain a text, and then with the key B, for example, it can contain a variable. It can contain another dictionary. It can contain whatever you want. So the dictionaries are a fantastic instrument for easily organizing a collection of elements. So let me go back a bit to the presentation because the dictionary is the basic structure of the openhdmg file. It has a number of keys that we will see later on. And the keys and the content of the EMG file dictionary is the same regardless of the source from which you are importing the EMG file. So in openhdmg, you can open files that are coming from MATLAB, you can open files that are coming from Python, that are coming from Excel, from wherever you want, more or less. But no matter what you're opening, you will always deal with an EMG file that is a dictionary, okay? We need to look at the keys in the dictionary. So once again, we print a formatted string where we say EMG file keys are. Now we need to pass a non-text component. So we use the curly brackets and we write EMG file dot keys. Okay? So EMG file is a dictionary. A dictionary has some attributes, simply functions specific of the dictionary that can be accessed with the dot indexing. Okay? If you see here, keys is yellow. If you hover over it, it's a method which is called method just because it's inside a class, but never mind, it's in yellow. So it's a function for simplicity. Being a function, we need to put brackets, okay? Otherwise, the code will not work. I put another blank line that I really love, and we can print that stuff. So EMG file keys are this. So inside the EMG file dictionary, we have a variable, a key, better say, that is called source, another one that is called file name, another one raw signal, reference signal, accuracy. If you are a bit familiar with electromyography, you know these terms. If you're not, it doesn't matter because these are text. Any text is associated to something. If you want to see what there is, for example, inside, let's start to something simple in EMG, to what there is inside the raw signal, we need to index the raw signal key. I told you before that indexing is done with square brackets. So in this case, let's modify this, EMG file, let's say key, and now I do an error to display you an important concept. Raw signal contains this stuff here. So what happened? Why I have white text? Everything is so colorful and nice in Visual Studio Code, but now there is something white. And I also have, I don't know if you see it here, but there is an error. So that is telling me that the bracket was not closed. This is because I put a string, this one, inside another string, this one, with the same hierarchical level. So this is not going to work. The code will give you an error. You can see it here, invalid syntax. So if you want to put a string, something that looks like a string inside the string without breaking the string, because here we are saying the string starts here and ends here, and then another one starts here and ends here, we need to use the quotation mark with a lower hierarchical level. So we use the single quotation mark, okay? We correct this, and now the colors are back. Nice. So, okay, we have our formatted string with the correct hierarchies of the quotation marks. But now let's go to the important part, which is indexing the raw signal key. Indexing, as I told you before, is simply done with square brackets. And inside here, I write with the single quotation mark raw signal. Okay, let's see what happens. Okay, so that's a bit large. But EMG file key raw signal contains this stuff here, which is a bit misformatted, but it's a table. It's a table where the first column is named 0, the second one is named 1, 2, and up to 63 columns, okay? And we can see here 64 columns. Now wait, I said 63, and here we have 63. Why we have 64 columns? This is because Python is starting from 0, so from 0 to 63, there are 64 elements. And that's the major and the trickiest difference between, for example, Python and MATLAB, because MATLAB is base 1, while Python is in base 0. So whatever we do in Python starts from 0. Whatever we do in MATLAB starts from 1. So we need to be careful to this aspect. So this is a table with 64 columns and 66,000 rows. If you are a bit familiar with electromyography, we can guess that every column is a channel of the recording grid, and every row is a sample in time that we are recording. So, but I mean, we guess that it's a table. We don't know that it is a table. So what we can do is to print the type of this, the type of this, okay? So we simply print the type of EMG file inside, so of what there is, the raw signal key of the EMG file dictionary. I miss a bracket. All right, and this is a class, once again, we don't care, but this is a pandas core frame data frame. This is the last part, is usually the one that we care about. So the raw signal is a data frame. A data frame is a data structure that we will use a lot. It is, in simple words, a table. Indeed, it's a specialized table that can contain any type of data. So it can contain an integer number, a number with decimal places. It can even contain text or complex numbers, okay? So numbers with an imaginary component. And these tables can be used for various operations. First of all, they are very useful because we can associate the data with a label, which is the column name. And also because they have a lot of built-in functionalities to easily explore and manage the elements that are contained in the table. They also have built-in methods or functions, to make it simple, that can perform fast numerical processing, so they can perform mathematical operations, they can show you what is contained in the data and so on. But they are a table, a much specialized and sophisticated table. Okay, now let's say I want to eventually see what really contains the first column, for example, of the table. I can use the PLT library that we imported before. We use the plot function. Don't care about this. We will look at it better in the future, but at least you realize what is contained in this table. And let me copy this, we are faster. So we can plot the raw signal in column 0. Once again, we use square brackets because we want to access the column 0, which is the first one. But just because the columns are named 0, 1, 2, and 3, if the column was named col 0, I could write this, okay? So here I write the name of the column that I want. Now I am plotting the data, and now I need to display the data. So let's execute it. And there we go. We see an electromyographic signal. If you use electromyography, you are, of course, familiar with this stuff, okay? So we looked at the content in the terminal, we looked at the content visually, but now, I mean, we have so many keys. Do we really want to stop here? No, because it's probably too little. Just let me copy and paste the code because it's the same exact thing, except for the fact that this time we want to look at the IPTS variable. The IPTS variable is the decomposed source, so the one that is actually allowing you to select the times of firing of the motor units. That's not important now if you are only interested in the Python aspects, but if you're using electromyography, I'm sure you already saw that. So, as you can see here, what is contained in the key IPTS? Once again, it's a data frame that we already know, but this time we have 5 columns that go from 0 to 4, and once again, 66,000 rows. The 5 columns, I tell you, that are the number of motor units. So in this file, we have 5 motor units, and therefore we have the decomposed source of each motor unit. So we repeat what we did before. Once again, we plot the IPTS that is contained in the ENG file. This time I want to, just to change a bit, I want to display the second motor unit, which is the number 1. Okay, and there we go. This is the source. These are the firing of the motor unit. This is the noise. And this is a nice motor unit. Now we looked at dictionaries, we looked at data frames, we looked at strings, and now we want to look at another 2 structures that are lists and arrays. So we want to look at the motor units pulses. So once again, I use the print function, a formatted string, and we say emg file motor unit pulses. Contains, let's say, is of type formatted string, and we say type emg file of motor unit pulses. So if you forgot, I'm not inventing the motor unit pulses. These are simply the keys of the dictionary. Okay, there we go. Sorry. So these are the keys that are contained in the dictionary. Okay, let's see what is contained in what type is mu pulses. This is a list. A list is a collection of elements. It is actually quite similar to dictionaries because inside the lists you can put, once again, a lot of different things. So you can put complex things. But compared to the dictionaries, they do not have a key. So you can only access the element in position 0, in position 1, in position 2. They do not have any name. So lists are memory efficient. Lists are fast and convenient to use, but you must remember in which position you put things. Otherwise, you do not have any way to understand what there is inside the list, okay? So are a simple collection of elements that can be accessed by position, but not by keys. Okay, let's print let's see actually how long is my list, because as I told you, it's a collection of things, and we need to know how many elements there are inside. So I simply write len, which stands for length, emg file motor unit pulses. So we have 5 elements that are the 5 motor units that we have. So we can, for better visualization, we can print the first element of the motor unit pulses. which is this stuff here. So it's a collection of integers, and these integers represent the time of firing of each motor unit. So this stuff here looks like a list because lists are defined inside the square brackets. We will define one of them later on. But it's always a terrible idea to guess what things are based on how they look. So we want to...
Giacomo, can you maybe explain what an integer is, since you specifically said it?
Yeah, all right. So an integer is a number without decimal places. If we have decimal places, they are called float values, okay? So if this 4,000 was 4,000.15, but also 4,000.0, this will be called a float, and now it's called an integer because we do not have any decimal place. Thank you, mate. So let's see, even if they look something, let's see what they are in reality. So once again, we print the type. And there we go. The type is a NumPy and the array. What is an array now? So if you use MATLAB, an array is a collection of numbers that are one-dimensional. If you use Python, an array is a collection of numbers that can have any dimension. So we call it array if we have a one-dimensional series of numbers. We call it two-dimensional array if we have two dimensions. We call it n-dimensional arrays because we can have any number of dimensions that we want. So arrays are probably the most complex data structure because they have a lot of restrictions in what you can put inside. Indeed, you can only put numbers, integers, float, complex numbers, but numbers. They do not have any label, so you can only access them by position, which are the coordinates of the various dimensions that they have. So they are complex, but they are the structure that is specialized in storing and processing numerical data. So they will be extremely fast and extremely accurate when it comes to do numerical processing. So the arrays are the one we usually use inside the functions, but we decided to make them rarely used by the user because of this complexity. So openhdemg has been built to be simple, which means most of the time you will interface with dictionaries, you will interface with tables that are very user-friendly, and the arrays are usually dedicated to the developers that write the functions optimized to give you a nice performance when you execute the code. Okay, hold on because we are at a good stage. So we have seen that there are a lot of things inside the EMG file. If we want to look at each of them one by one, I mean, it will take likely forever. And so we have a specific function in openhdemg that allows us to look at all the things at once. This function is contained inside the info class, which is a library, which is a class, but we don't care. We use it as a library. Inside the info, as a function. Inside the info function, in this case, we can call other functions, and we are interested in data. Okay, this is yellow. This is a real function. And inside the parentheses, we have written EMG file. We have a parameter that is the EMG file. So it means we need to tell this function what is the EMG file. And the function is going to print a description of the EMG file data structure. So it will done all the work we did so far. But at least you know how to do it yourself. Okay? we execute the code, and as you can see here, we have a lot of stuff in the terminal now. So the data structure of the img file is a dictionary. There are the following keys. Any key can be accessed as img file square brackets keys, and then we see the source is a string, the file name is once again a string, and then we have the raw signal, which is a data frame. We have the reference signal, which is once again a data frame, and so on. We have a lot of data frames. We have the list, we have the array, and then we have float values, integers, okay, and so on. So today you got the tools that are needed to look what elements is the one that you are interacting with, but you also understood what is the use case of the different, let's call them elements of the different data structures that we have in Python. Now we are going to give a meaning to what we have seen so far, but I think we have like 10-15 minutes left, so don't worry, it's not too much, because we want to look at the two basic constructs of Python that are the for loops. For loops are your best friend because they will allow you to automate the majority of your code. They are created in a very simple way. Once again, just writing normal English. So for I in something, so this I can be called B, can be called hello, can be called whatever you want. I can call it for number in something. So I need to iterate over something. The easiest way to do this is to create a range that is composed of a number of values. So what we are doing with this code is to tell the script. So I have a range of 10 elements. 10 elements, it means they go from 0 to 9. So I have 0, 1, 2, 3, 4, and up to 9. And at every iteration, my variable number will become one element in this range. So the first iteration number will be 1, the second iteration number will be 2, and so on. So let's see if this is true. So print formatted string iteration. Oh, gosh. Iteration number, and here we write the number of the iteration number. Okay, and this will happen very fast, so we just add a bit of delay in the print. Okay, don't care about this. We are just saying from the time module to use the sleep function to add 0.5 seconds of delay, okay? And as you can see here, iteration number 0, iteration number 1, iteration number 2, up to 9, okay? So in this case, you can perform any operation because you want to do something different based on the iteration you're doing. Now we can look at another important stuff that is the colon at the end of the for statement. We always need this in Python, otherwise we do not create a for loop. But also we need to be very careful with the indentation. So when we do a for loop, when we do an if statement, when we do other particular things, we need to have an indentation in the code. So in MATLAB, you can write it all together, and you write end when when your things are finished. In Python, you do the same. You need to tell the code where the for loop starts and where it ends, but you do this with the indentation, okay? So if here you print something, here your for statement is finished, your for loop is finished because you went back to the previous level of indentation. That's at the beginning causing a lot of issues, but just remember that you need to be careful to that. If we do not put the indentation, we get immediately the error expecting the indent block. Okay? So we put the indentation. Now, something very cool about Python is that we can iterate over everything. So we do not iterate over numbers only, but I can iterate over custom values that I call my values. I put all the values inside the list that I can simply create by using square brackets. And so the values I want to have are 2, 3, 6, but they can also be different. I mean, they can be 3.6, they can be a text, okay? So I can iterate inside these elements. And in this case, okay. In this case, I will say iteration number contain. Okay, I need to. Okay, I write iterate for number in my values. Okay, so at the first iteration, my number will be 2. At the second iteration, my number will be 3. At the third iteration, my number will be 6, and so on. And the last iteration, my number in reality will be a string. But in this case, I want to know both the value that is contained inside my values and the iteration that I'm doing, because I mean, I want to know at what stage I am. To do this, we can use the very nice function enumerate, which is returning the position, the iteration. We can call it iteration if it's easier to understand, and the value. Okay, so it is returning the first position, the iteration, that will be 0, 1, 2, 3, and so on, and the value, which will be 2, 3, 6, and so on. So you can write iteration number, iteration is, here we simply show the value. Okay, let's see if that works. Okay, iteration number 2 is 0, iteration number 1 is 3, and so on, and iteration number 4 is hello. Okay, we covered more or less the what you really need to know about for loops. Now we quickly look at if and else statement. So I create a variable is called x and contains the value 1. And I can say if x is, and in this case we use equal, so if x is the same as 1, colon, indentation, print, x is 1, okay? Perfect, so x is 1. So let's change it to 2. So this time it will not print anything, but the situation will not be cached. So we want to say if x is 1, print x is 1. Else, if, so, and it's written elif in Python, else if x, we can say, is greater than 1, and we simply print x, we need a string, of course, x is greater than 1. All right, x is greater than 1. In the end, we can put 0. We maybe do not expect this value, so we can say else, so whatever happens that is not x equal to 1, x greater than 1, or any condition that we specify, will result in the execution of this block of code. And here we can print, I don't know, unexpected x value, okay? All right, and we get unexpected x value. All right, we did data types, we did for loops, we did if, else, elif statements. So I guess you are tired enough. So just to quickly show you what we can do with this information. Now, don't worry about this. It's just to show you that things that actually seem too basic in reality have a lot of, let's say, use cases. These are going to be the building blocks of all your code. Just give me, just survive for 5 more minutes, because now we are going to plot the discharge rate of various motor units, okay? I want to plot some motor units. So I create a list of values, and I want to plot the number 1, the number 3, the number 7, okay? But we saw before that in our file there are only 5 motor units. And also I don't want to plot them one by one. So I will use a for loop that is only plotting the motor units that are really contained in the EMG file. So I can create a variable that is called total number of motor units, which is can be obtained by accessing the EMG file key called number of motor units, okay? So we want to plot motor unit 1, 3, and 7, but we only have 5 motor units that we can know from this variable here inside the EMG file dictionary. Let's start by creating the for loop. So for motor unit number in motor units to plot. So this motor unit number will be 1, then 3, then 7. I want to plot the motor unit only if it is really contained in the file. So we use an if statement. If motor unit number is smaller than the total number of motor units, and we say smaller because Python is in base 0, so the 5th motor unit will be the number 4, we can plot the instantaneous discharge rate. Now, don't worry about how this is done, because it doesn't matter. We plot it, but we also want to do something in the case where we do not have the motor unit. So if the motor unit number is present, plot the instantaneous discharge rate, else tell me that I do not have the motor unit. So I can print motor unit, and here I put the into the formatted string. I can put motor unit number is not present. Okay, so we are done. We did a for loop where we plot the motor units that I want to plot only if they are present in the EMG file. Let's see what happens if I execute it. We see the motor unit, the discharge rate of motor unit number 1, which is here. We see the discharge rate of motor unit 3, which is here. And now what happens with motor unit 7? We print motor unit 7 is not present. All right. We are perfectly in time, 1 hour and a half. We saw a lot of basic information that can be quite complicated if you are not familiar with coding. I guess they are interesting if you are familiar, for example, with MATLAB and so on, because there are quite a lot of differences. And you will have all the code, all the recording, and you can practice yourself. So for the next class, we will start talking about more advanced topics. Or please let us know if you would like to go deeper into these fundamentals. So thanks guys for listening. Let's have a Q&A session.